Now, a lot of the pitfalls in machine learning tend to boil down to this learning and teaching thing. People just lose the common sense of learning and teaching. They don't think about that. They get so stuck in the math. So I implore you to think about this carefully first, and then you can think about the mathy stuff if you wish to. This is obvious when you have it spelled out for you, and yet you keep seeing these disastrous things over and over again that just are this obvious stuff. So let's look at these obvious things. First, you want a calculus-enabled student. You should use relevant examples. So the only thing that the student's going to learn is what's in the textbook you give them to study from. Just because you have textbooks doesn't mean your student is going to learn awesome stuff. What if those textbooks are Japanese-English vocabulary pairs? How is that going to help for calculus? Now, your student will be able to go and find patterns in that and learn it, but they won't do the task you need them to do. So we need to stop saying data with a capital D, like just having data makes things magical somehow. And even worse, data with a capital D plus the holy water of machine learning means it just works. No, data is just examples, information, and you are trying to express yourself by example. Your examples should be relevant. And so I say to Google engineers, if they're going near machine learning, they should consider tattooing this sentence on themselves. The world represented by your training data is the only world you can expect to succeed in. So you are in charge of what's in your training data. And if you pick a silly training data set, you're going to be able to succeed in the world represented by that data set. That's just not the reality that you inhabit. So your system's going to crash and burn in the real world. A classic example is one where you're interested in all your users, and the data that you choose to learn from is your users who inhabit an island near Antarctica or something, and nobody else. Those users might be something unique and special about them. They don't represent the whole world of what you're interested in, and you'll build a system that succeeds there, and then you'll be so surprised why it fails in New York City. That is your fault. You are supposed to open the textbooks, check that you like what's inside them. And a lot of this stuff about bias and fairness in machine learning also boils down to this. If you choose textbooks that are written, collected, curated in a way that reflects the biases of the humans who did that curation, your system's going to learn that stuff. And whose fault is that? Jointly, the author of the textbook and the professor who failed to check whether that textbook was something that you wanted to give to your student to study from. And so really checking your data, making sure that it's relevant, making sure that it describes the reality you want to succeed in, that keeps you safe. And it keeps you away from these surprises that people don't see coming that they really should have seen coming. The other one is catching memorization. The whole job here is not to parrot, but to succeed on new stuff. Otherwise, we wouldn't need machine learning. And you fail at your one job if your system can beat your test by memorization. So please design that test so it can't be beaten by memorization by having a truly pristine data set to test on. If the system has seen the data set in any context already, it is not okay for testing. And the system is jointly the algorithm and the human working on it. The human knows some stuff about how this context works and kind of knows how to arrange all the pieces so that they can get a good performance. If the human already knows too much about that data set, they know how to beat it. A good data scientist is a scary thing.